Hi everybody, so in this video we're going to do another PDM network. It's going to be a little bit more complicated, and we're going to actually incorporate total floating and free float concepts. Again, these are going to be used to help work out the critical path, which we didn't exactly do properly in the previous video. But if you haven't watched the previous video in this one, please go ahead and watch that first of all, and then this one will make a bit more sense to you. But let's get started. So in this one we have our table, we have our activities, our predecessors, and our durations. So again, step one is going to be just to draw a rough PDM or do a rough diagram just so we know where all the activities are going to be and the nodes are going to be laid out. So start off with activity A, and we're going to activity B then. So activity B has a predecessor of A, so we can put this one up here. Activity C also has a predecessor of A, so we can bring that one down here. So it's obviously now both C and A both have the predecessor of B and C have a predecessor of A, as you can see here in the diagram. Activity D is next in the list, and that has a predecessor of B. So that means B goes before it. So we have D here. Activity E has a predecessor of C. So we can see that goes in here. Activity F has a predecessor of C as well, so obviously we need to bring down a second arrow from C for F. So that's our F. Activity G has a predecessor of both D and E. That means both D and E have to be completed before G. So we have D and E here separate, so they're also going to come together for activity G. And then activity H has a predecessor of both F and G. So we've done our G up here, we have F here, so we can just put H out here and have G come down towards it, and then F coming up to it like this. So now we know roughly what our diagram is supposed to look like. So then we can go back, and now, knowing this information, we can then use the nodes, which we had done in the previous video. Again, if you don't know what the nodes are, I'll just draw a quick sketch over here. And so our node is just a little box with a few different bits of information inside it. And again, just for clarity, I'll just use the B. So the activity ID goes in the center one, and the duration goes down here. And then we have the early start time goes in the top left box, and the early finish time goes in the top right box. And again, just to keep it going green. And then the late finish time goes in the bottom right section or box, and the latest start time goes in the bottom left. So that's what our nodes should look like. Hopefully yours look a bit tidier and neater than mine. But anyway, once we know that's where everything's going to be, we can actually then, using the rough diagram we've drawn up here, we can then draw actually our proper PDM network using the nodes. So I'll draw this all by hand, so bear with me. So this is our first node here for A. And then I'll just draw all the nodes first of all, then I'll fill in the details. So this is going to be B. Then we go to D. And then we have G is next. Again, this way it's always good to do the rough sketch first of how the network's going to look, so you can know where to put the nodes. And if you're using software, you could actually position these and drag them around, but obviously if you're doing these in an exam question or by hand, you want to know where they are so you're not wasting your time rubbing things out or erasing anything. So this is going to be for activity C. So we have E and F left to do. So let's bring E up here, and then F is going to be down here. So this was E, and E is going up to G, and then we've F down the bottom here, and this is going to go to H over here. So I'll just draw a final box over here. Bit cramped my screen, but hopefully I'll fit everything into the thing. Let's divide that a little bit better. And then we'll use our arrow here. So actually just out of my, I'll just fix that one, that looks a bit untidy just so we don't run out of space. So this is just for F. And again, that goes up to H, and then we just connect down there. So now we have basically the layout of our PDM network here based on the rough diagram. So now we can start filling in the information. So again, I'll use the color code which we were using there a minute ago. So the activity ID, the first one obviously is A, and the duration is going to be 4 days. Then we go up to B, so we have B here, and the duration is 5. C is next, so if C is down here, and the duration is 2. Next one is D, so looking at the rough diagram, D is up the top here. So we have D, and the duration is 6. Next one is going to be E, and the duration is 2. Next one's going to be F, which is, I forgot how to write F there, my brain's going a bit slow, so we'll try that again. So F goes here, and the duration is 3. Next one is G, and the duration is 4. And H then is here, and the duration is 3. So again, this is kind of, again, logical enough. So again, it's just using the information from the table. We have activity A has no predecessors because there's nothing before it. It's the first one. Activity B up the top here, its predecessor is A as in the table, so A always has to come beforehand. And again, it's the same, follow the same logic, just using the information in the table, put in the information for the activity and the duration. So what we can do next then is we'll start filling in the early start time and the early finish time. So that's going to be doing the forward pass. Again, if you watch the previous video, that's what the first thing we're going to do. We're going to do a forward pass to work out the early start time, the early finish times. And then we're going to do the backward pass to work out the latest start time, the latest finish time. So again, we'll go to color coding so you can follow along. So obviously for activity A, the earliest start time is 0 because it's going to be starting on the very first day. So day 0 is the activity A. And again, to work out the early finish time, which is going to be the top right box, it's going to be 0 plus 4, and then we're going to put 4 in here. So now we can just go on to the next one. So we'll just go up along the B here. So we're going to work out the early start time for B, we just carry over the early finish time from activity A. So that's going to be carrying the 4 up here. And again, to work out the early finish time, it's going to be 4 plus 5, which is going to be 9. And we carry over that 9, the early finish time for 9 from activity B, it's going to be the early start time for activity D. So bring over the 9. 9 plus the duration is 6 is going to be 15. And we're not going to fill in G just yet because you can see here there's actually 2 nodes going into G. We've node D for activity D, and then activity E here. So we actually have to work out E, what E is first of all before we do that one. So let's go back and we'll start doing node C for activity C, I should say. So again, for activity C, the early finish time for activity A is 4, so we're going to bring that 4 down to C. And then 4 plus the duration of 2 is 6. Again, we're going to bring that 6 up to the top here for activity E. So bring in 6. 6 plus 2 is going to be 8. That's going to be our early finish time for activity E. And before we go to the next one, let's go down and do activity F. So we're going to bring down the 6. So the 6 is the early finish time for activity C. And F is obviously connected to it because F or C is a predecessor of F. So we'll bring the 6 down, stick it in here. Then 6 plus 3 is going to be 9. Okay, so now we can actually fill in we can't do H just yet because we need to actually get information from G and F to fill in H, if you see, which is actually the correct start time to bring over. So but before we do G, we have to do the same thing for D and E. So we're going to look at D and E. So if you watch the previous video, we have the early finish time of 15 in activity D. So day 15 is the earliest activity D can finish. And for activity E, the earliest finish time is going to be day 8. So in this case, we're going to pick the largest number because logically, if you think about it, if we carried over the 8 into activity G, that means G can actually start on day 8. However, activity D is going to take 15 days. So if we started activity G on day 8, it actually wouldn't work because D wouldn't be complete yet. And activity G has a predecessor of D and E. So when it has a predecessor of something, that means that activity G for activity D and E must be completed before you can actually start activity G. So what that means is we just pick the largest early finish time. So for this one, it's going to be 15. So bring the 15 down here, and then it's going to be 15 plus 4, which is going to be 19. And then we'll go down and do H. So again, we have to work it out. Same thing again. You can see on activity F, it's going to be the early finish time is 9, and activity G, the early finish time is 19. So for the forward pass, we always pick the largest number. So it's going to be 19. And then we go 19 plus 3 is going to be 22. So now doing our forward pass, we've actually calculated that the project duration is going to be 22 days. So that's our forward pass complete. So I'll just swap colors so you can follow along. So we're going to do the backward pass now. So it's basically the exact same thing we did there, except it's going in the opposite direction. And this is going to help us work out the latest start time and the latest finish time, as you can see here in the node. So let's go on. So to get this going, we just kind of bring that 22 down here, because that's the latest finish time. So again, last time we were adding the early start time plus the duration to get the early finish time. Again, for the backward pass is just the exact opposite. So it's going to be the late finish time minus the duration is going to give us the latest start time. So it's going to be 22 minus 3, and put in 19 here. Looks good. So we'll bring the 19 up to activity G first of all, because it's the closest one. So 19, and we have 19 minus 4 is going to be 15. That's good. So we bring the 19 back down here then. So 19 minus 3 is going to be 16. So that means the latest start time for activity F is going to be on day 16. And we can't fill out activity C yet, because you can see there's actually 2 nodes going into activity C. That's activity E and activity F going in. So we have to actually figure out what the latest start time is for E first of all. So we'll go back up. So we can bring down, we'll start off with activity E. So we'll bring the 15 from activity G down here. So we put 15 down here. So it's going to be 15 minus 2, it's going to be 13. And then you can see here again, because last time we did the opposite, we're going to do the opposite we did for the forward pass. So what that means is, so just check everything is recording okay. Yep. So what that means is we're going to bring down the lowest number. So in the first time when doing the forward pass, you always pick the largest duration of an activity to carry forward, because that's just the way it is. Doing the backward pass, you pick the smaller of the number. So here we have the latest start time is 13 for activity E, or 16 for activity F. So we're going to pick the smallest one. So it's going to be 13. We're going to carry over. So we have 13 there. And then 13 minus 2 is going to be 11. And we go back up. We can't do A just yet, because it's actually both A and B are going to influence what B and C are going to influence what the dates are, what the times are in activity A. So we'll go back up to D is the next one we can do logically. So we've got the late start time of 15 in activity G. We're going to bring that over. So that's 15. Then 15 minus 6 is going to be 9. That's all good. So we bring that 9 over to here. And then that 9 minus 5 is going to be 4. And again, like we did last time, now we have a latest start time of day 4 for activity B, and a latest start time of day 11 for activity C. So obviously for this one, we're going to pick the smallest one, because that's what you do in the backward pass. So we're going to bring the 4 over here. And now we actually have 4 minus 4, and that's going to be 0. So you can see here now, that's actually, this is how we actually fill in the network diagram. So we've got all our early starts, our early finishes, late starts and latest finishes all drawn up. So what we could do next to identify the critical path, we showed you a kind of a quick way to identify the critical path. There is a way we can actually do it using a thing called stacks, floats or stacks. I think they could be terms that you use interchangeably. So total float or total stack. But I'll explain what that is now. So this is what we'll use to work out the critical path of the project. Okay. So the total float is actually, or you can call it total stack sometimes, is actually the total float or total stack. That's the largest number you can actually delay a project, delay an activity without actually delaying the whole project. So we'll show you now how to work that out. So again, there's 2 ways we can actually calculate the total float. So I'll just get my pen up here. So we have total float. I was going to call it TF. So total float equals there's two ways. So we can do it using the latest finish time minus the earliest finish time. And that's going to be called the finish float. Or we can use the other option, which is going to be the latest start time minus the earliest start time. That's going to be called our start float. They're both the exact same thing, and they should be all the same throughout, depending which way you want to do it. So it doesn't really matter which one you want to do. So we'll do a few examples here to show how it works. So one of the ways we're going to work out the critical path using this method is that any activity has a total float of 0 will actually appear on the critical path. So we'll do our few calculations here now, and we'll identify all those with a total float of 0, and they'll help us identify the critical path. So we'll start off with activity A. So in activity A, we'll just write it above it now. So usually just write the number above it, but just for clarity, so again, usually put the total float number just above the node. So for this one, a total float for activity A, so we'll do it both ways, you can see. So we can either do the finish float or the start float. They should be the exact same. So late finish minus the early finish. So you can see on our node is going to be, so we see that's going to be this number here, late finish minus the early finish. So in this case it's going to be 0 minus 0, which is obviously 0, or 4 minus 4 if we were going to use the start float. Sorry, so start float is actually the 0 and 0, and if we're going to look at the finish float, it's going to be the latest finish time minus the early finish time. So well, in both cases anyway, the total float here is 0 because they both equal 0. So again, we can just write it here. So we'll go on to activity B. Again, you can see here that if we're going to do either the finish or the start float, it's going to be 4 minus 4. So a late start of 4 minus the early start time of 4, it's going to be 0, and then you can see 9 minus 9 is 0. So again, total float equals 0. For this one, again, same again, 9 and 9, 15 and 15, so total float equals 0. Same again, 15 and 15, 19 and 19, total float equals 0. And again, the final one here, activity H, usually it's obviously the first and the last in a row is going to be on the critical path, but anyway, we'll just do it just to be sure. So total float, so we have our 19 and 19 and 22 and 22, they'll all, if you take each of them away from each other, it's going to be 0. And just to double check, obviously we have our critical path identified there, but just for working things out properly, we'll just go and actually do the same thing for all the other nodes, just to make sure we have everything covered. So for activity C, we'll do the start float just for this one. So it's going to be the late start minus the early start time. So it's going to be 11 minus 4. Sorry, 2 seconds now. So that's going to be 7. So total float here is going to be 7. So again, it's the same thing as if it's 13 minus 6 is also 7. For activity E, it's going to be 13 minus 6 again, or 15 minus 8. And again, that's going to give us 7 as well. For activity F, we have 16 minus 6, or 19 minus 9. So that's going to be quite a big total float. It's going to give us 10. And again, that's a ID there. So you can see now just from this example that our critical path, I'll just highlight it using the text here. So just highlight all the total floats. So again, you identify the critical path by identifying the nodes that have a total float of 0. So our critical path here is obviously going from A, B, D, G, and H. So let me just draw that there. Okay, so yeah, we have it highlighted there. So that's our critical path. So let me just write down the critical path up here. Let's put a space up here. So critical path equals A, B, D, G, and H. That's a G. So now we have our critical path. And again, in the previous video, we were just using a quick look. Again, using the total float is how you're actually supposed to do it. So in an exam question, you have to identify and write down your total float, so your total stack, whatever you want to whatever term you're using. So now we have our critical path. It's going to be total float of 0 identified. What that means is basically all those activities cannot be delayed at all. So if there is a delay in any of those activities, that's going to affect the overall project duration. So for example, if there's actually an extra day added on to activity G, that means actually that's going to be carried over into activity H, and it's going to be, instead of being 22 days, it's going to be 23 days. So when you have a total float of 0, that means there's actually no float or slack within those activities. So you have to really make sure that those activities are running on time, because again, that'll actually affect your overall project. And again, delays in projects, especially construction projects, can cost a lot of money. So, but if you look at the other nodes or the other activities, so activity C, for example, that has a total float of 7. That means that activity could potentially be delayed by up to 7 days, and it wouldn't have a negative effect on the overall project duration. It means it wouldn't actually add on to the overall project duration because it has a float of 7 days, which means you have a bit of play there. Again, the same thing happens for activity E. That also has a float of 7 days. So again, that doesn't have that. You have 7 days that could be delayed by without affecting the overall project length. And again, activity F is even greater. That has a total float of 10 days. So again, that could be delayed up to 10 days without affecting the project timeline or the project end date. Again, that's not the case for the critical path. Anything on the critical path with a total float of 0, if that is delayed by a certain number, that whatever that number is will be added on to the overall project. So again, identifying the critical path using this method is very useful, because it does means that project managers can then identify the tasks that need to be really keep an eye on it and make sure everything's going to be working on time. So again, you don't want any projects getting delayed too much, because it's going to cost a lot of money in the future. So here we have our final network diagram. Another thing you may be asked, I know when I was doing the calculations, I actually wasn't writing out the calculations because they're fairly simple calculations, but you may be asked to write out the calculations in an exam purpose or in an assignment purpose, just to show that you've actually understood what's going on. So I'll just go through a quick example of how you could actually write these out. So we'll just scroll down a little bit. So this is going to be just a sample calculation for node A or for activity A. So when we start off with the sample calculations, we're obviously given a start time. So the early start times, this is what the red 0 up in the top left corner is. So that's actually going to be given. And then in each node going on, remember, we're going to carry over the early start time, because the early start time is equal to the early finish time from the previous activity. So for this example, the calculations that you would have to do, so the first one would be, let's select the right color pen, that's fine. So the first one is going to be the early finish time. So early finish time is going to be the early start time plus the duration, which in this case is obviously for activity A, it's going to be 0, because this is what the 0 is, the early start time, and the duration is given here, so that's going to be plus 4. So then early finish time equals 4. So very simple way of actually just calculating out writing out the calculations for the actual early start time and early finish time. You can do the same thing then for the late start time and late finish time as you're required. So, but if you're asked to put out the calculations, this is what you have to do. So there's lots of writing it out, but at the same time, at least if you see it written out, you have a better chance of actually getting them all correct, because you can spot mistakes a bit easier. Another thing you will be asked to do, or you'll probably be asked to do in most questions, exam questions or assignments in the future, is you might have to actually put all this information here from the diagram into table format. So obviously we were given a small table to start with activity, predecessor and duration. Usually you're going to be asked to kind of summarize all the extra information we've put together into a bigger table. So in this diagram we've actually calculated the early start time, the early finish time, the late start time, the late finish time, and also then the total float for each of the activities. So usually you'd be asked to tabulate all this information into one. So for this network diagram, I've actually prepared a table down here. So this is what a table would look like for this diagram, for this network diagram. So again, we have just the activity, the predecessor and duration. This is the same as we were given in the original start question at the start. Again, then we just added a new column for early start time, early finish, late start, late finish, total float and remarks. So again, all you have to do then, once you've actually done the calculations, and again, you probably have to write them all out like this to show that you've actually done them and you've filled in all the nodes. You basically just have to go look at each one of the node and just put the right number into the right box in the table. Straightforward enough. For the remarks, all that has to be is actually, that's just writing in which is the critical activity. So obviously for this example, activity A, B, D, G and H were the critical activities. Let me just double check that is correct. That was right. So again, that's all it is. If it's not part of the critical path, then you just leave it blank. If it is part of the critical path, you just write in the word critical. Straightforward enough. So again, for any examples you might have to do, you will be asked to put all that information in tabular format. So have a look at this, and if you're not sure, just go back over the video. And again, if you have to do any sample calculations, this would be a sample calculation for the early finish time. The same type of calculation when you're going backwards then for the late start time, for example. And for any assumptions made, like obviously when you go to node B, you won't actually have to do a calculation then for the early start time for node B. So you can just write down like, you know, early start. Well, you can put like node or activity B. Early start time equals, obviously because we're going to carry over the 4, so early start time equals 4, and then you can actually do the next calculations, like so early finish time equals early start time plus duration, and then obviously it is whatever it is, so you just fill in the numbers. So you know, it'll be 4 plus whatever actually the duration is for activity B. So this is how you'd actually show the calculations as you're going along. Again, it's always good to write them out anyway instead of just doing them in your head. I know I did them in my head for this video, but that was just to save time and space because we just want to keep everything on the same screen. So that's everything you will be required to do for any assignments or questions or an exam questions, for example. So hopefully you've understood everything. If not, just go back and watch the video. Again, there's other resources on YouTube explaining things. Like there's a YouTube channel called Engineer for Free. That's 4, like the number 4 and then free. And that channel actually explains the network diagram stuff we've done here in kind of nice bite-sized portions, like small 3, 4, 5 minute videos. So they're quite good if you want to kind of look at something in smaller time scale as opposed to this long video like this. But hopefully everything has been explained clearly to you, and we will see you in the next video.